K minus
D. I can see that it.
That's the same homotopy type as the equator. S
Yeah.
minus 1, so that's like...
Those defects at the south and north pole grow until you get to the equator.
So, trying to remember if we had notation for homotopy types. That's a nice one. Which we had defined here as K minus 1. You know what? Let's see. Alright, so using Viator. We have an exact sequence. HP tilde of x1, xm, HP tilde of x2. Okay, there's your for this. HP tilde Sn. HP tilde HP minus 1 tilde. Can you still see that? I don't know if you, I might go to the next
Yeah.
one.
Oh, you're fine.
We're good? Alright.
I'm looking here.
Of x1 intersect x2, which you said is same homotopy type as K minus 1. And I'll do a little indent to show the last part. HP minus 1 tilde of x1 to xm, HP minus 1 tilde x2. Okay. And so x1 and x2 are both contractible, which shows that this is 0. This is 0, exact, this is 0, I think. And these are both 0 as well, so this is 0. So we have a short exact sequence, I think. Okay, and let's see. Sorry. Right, so because...
Induction.
right. Sorry, I'm drawing a blank here.
Well, the x1 intersect x2 is essentially Sn minus 1, right?
Yes. Is isomorphic to HP minus 1, which is isomorphic to sure this is some using case.
Huh.
Okay, hold on. I'm trying to make sure I understand what's going on.
Yeah.
By corollary 4.24. Okay, so these are isomorphic because they're the same homotopy type.
Right.
Okay.
I shouldn't say they're equal, but they, being of the same homotopy type, they generate the same homology, and I guess hence reduced homology here.
Alright, right by 4.24. And these are isomorphic because I think because of this exact sequence. So we have right, yeah. So we have this short exact sequence here, where this is 0, and then so this one, and then this is 0. So this has to be an isomorphism, I think.
It's cool how the exact sequence shifts the index down like that. You know, like you connect HP to HP minus 1, but then the x1 intersect x2 gets connected to the Sn minus 1, and then the way the index shifts both ways is neat.
Yeah, sorry. When I was starting doing the induction hypothesis, I used the wrong index.
Excuse me.
Assumes that it's true for sk minus 1, so but these are isomorphic, so he says that hp minus 1, h to the p minus 1 of sk minus 1 is equal to z if p minus 1 is equal to k minus 1 by the induction hypothesis and 0 otherwise. That means that hp tilde of sk is equal to the same thing, but if p is equal to k. Because we showed that these are isomorphic, and we assumed that this was true. So, therefore, if it's true for k minus 1, it's true for k, and so by induction, it's true for all. It's true for all n.
Excuse me. Huh.
It says, this theorem illustrates the value of reduced homology. Not only is the reduced statement better, but the proof is shorter. Without it, we have to jump through some hoops. Without it, let's see. Without reduced homology, the inductive step would divide into two cases, p minus 1 greater than 0, which proceed the same way as this, and p minus 1 equal to 0, which require an extra argument, involving free abelian groups, as in the proof of theorem 5.16.
Huh.
But we didn't really
You should go back and look at my notes from when I took this and see how we did it.
Yeah.
I can't remember. I do remember the. I do remember the South Pole North Pole thing. That was. I remember that.
Okay.
I'm not sure. Because there's a Biaviatoris for reduced and also for not reduced, right? So, like you had the.
Right. Yeah. Exactly.
So. Yeah. Huh.
All right. I think that's about all the time that we have for today.
Yep.
So, thank you all for.
Wow. Next time will be interesting.
Next time we'll actually find the applications.
We will finally
this
prove
stuff.
that Rm and Rn are not homeomorphic when m is not equal to n.
Yes. I'm so
It's
excited.
very exciting. Yes.